Bismillahirrahmanirrahim. Inshallah, we'll start talking about Math 102, Calculus 2, about these topics. So we'll start in the first section, 5.2, which is about the area. What we have? We have first talking about sigma notation. This is some of the formulas. You should remember it or memorize it. If we have the sigma notation, what's the meaning of sigma notation? Means what? I want to find the values. For example, this one means what? Means I'm looking for the values from 1 to n of these values, which means I need to add 1 n times. 1 plus 1 plus 1 plus 1 n times, which is very clear. This is n. Okay. If there is an I, you need to substitute I. For example, what's the meaning of this? It means when I equal 1, this is 1. When I equal 2, I need to add that 2. When I equal 3 plus n. And that is this formula, which is a well-known formula. N times n plus 1 over 2. And the same thing for the other formulas. So these are formulas we need to memorize or to remember so that we can use. These are some of the conditions. A constant times a relation in terms of I. You can take the constant out, which is not related to I. The sum can be distributed, and the difference and the sums can be distributed. Okay, because we need it when we find the area. Now let us talk about the area, or what we have mainly in this section. In this section, we are looking for what? You have, for example, a function from x0 to x1 or from a to b, and would like to estimate the area under that function. For example, I have y equal x squared. This is the graph of y equal x squared. This is the graph for y equal x squared. I want it from 0 to 1. I'm looking for this area. How to find this area? The idea is very simple. What we will do, we will split this area into subintervals. 1, 2, 3, 4. Who cares? Like this one. So I have intervals. I have this from 0. Since he is doing 4 intervals from 0 to 1, so for sure this will be 1 over 4, 2 over 4, 3 over 4, 4 over 4. Just to make it clear. So in the first interval from 0 to 1 over 4, how to approximate the area? I will make a rectangle like this one. I'll make a rectangle. And second interval, I make another rectangle, third interval, make third, and so on. Since we can find the area of the rectangle easily, what will be the area of the rectangle? It will be the width times the height. Here, this rectangle, width times the height. So instead of finding the area, I will find the areas of these rectangles. So that will be a good estimate for this area. So the procedure is very simple. What you will do first, you have this is A equals 0, and B equal 1. Then you will find the width, this width. Assume it's a fixed width. What will be the width? How many rectangles I need? For example, in this case, I need n to be 4. I need 4 rectangles. 4 rectangles. So just I'll find delta x, which is the width. This is the width. Which is what? B minus A, 1 minus 0 over 4, and that will be 1 over 4. Okay, that will help me to find these intervals. This interval. Very, very clear. The first interval will be 0, 1 over 4. Second interval, 1 over 4 to 2 over 4, which is half. Third interval, 2 over 4 to 3 over 4. Fourth interval, it will be 3 over 4 to 4 over 4, which is 1, which is the last thing. Okay, so now I have the interval. Now, to find the area, to estimate the area, not to find it, to estimate the area, as I said, I will use this rectangle. So I need the width. The width is fixed, which is 1/4. Always it will be 1/4, which is delta x. The height, now I have two things. Either I will use in this rectangle, for example, if I use in this rectangle, either I will use the right endpoint, which is f at this point, or I can use the left endpoint, which is f at 0, which is I will do it in the next case. Now in this case, using the left endpoint. So either I will use the right endpoint or the left endpoint. Okay. Now in this case, I'm using the right endpoint. So I will use this one. And for the first rectangle, I will use this one. For the second rectangle, I will use what? This height. For the third rectangle, I'll use this height. For the fourth rectangle, I'll use this height. So what are the heights? Since this is the point in the function, that will be in the first one, 1/4 square. In the second one, half square. In the third one, 3/4 square. In the fourth one, 1 square. Since the function is x square. Okay, so this is f at 1/4, f at half, and so on. Now I need to find the area of these rectangles. This rectangle plus this rectangle, which is, I know the area for the rectangle will be the width times the height. So the area of the first rectangle, S1, what will be the area for S1? It will be 1/4 times f of 1/4, which is 1/4 times 1/4 square. Okay. For S2, for the second rectangle, second one, assume this is the S2, the second rectangle, or yeah, they call it R. Usually they're using for the right hand side, they call it R1 or yeah, the rectangles. Okay, rectangles. We call it R for the rectangles. The areas of the rectangles. This is the first one. Second one will be what? Will be 1/4 times half square. Third one, 1/4 times 3/4 square. Fourth one, 1/4, which is just width times height, huh? Width times height times 1 square. What will be the sum? Will be the first one. This is 1/what? 1/4. Yeah, I can take 1/4 common factor. I have 1/4 square, which is 1/16. Yeah. Now I have 1/4 everywhere, so I can take it as a common factor. 1/16 plus half square, which is 1/4. This is what? 9/16. And this is 1. So the answer is what? 1/4 times what? This is 4/16. This is 16/16. This is 20, 30/16. Correct? Yeah, it will be 30/16. Which is, take this is out of 2. This is 15. So it will be 15/32. So this will be the estimate for the area under this curve. I want to find the area under this curve, which is this area, using these rectangles. So this is my estimate. You just notice, my estimate is more than the actual one, because you notice these rectangles, they are above. Yeah, this is the area. But the areas, this is the area, the main area, the area under this curve. But The areas of the rectangles will be more than my area, my actual area. Now let me do it with the left endpoint. We'll do the same thing. So it will be delta x 1/4. What are the subintervals? Same thing. 1/4 to half. And this is half to 3/4. And this is 3/4 over to 1. The width will be the same, delta x and 1/4. Yeah, fixed delta x. Fixed width. Okay, now the height is using the left endpoint. So I'll use these endpoints. So the first one, I'm using 0. There is no rectangle. So I have 0 square. These are the heights. Second one, only 1/4 square. Third one, half square. Fourth one, 3/4 square. What will be the sum? Yeah, the sum will be what? 1/4, 0 square, which is 0, plus 1/16, plus 1/4, plus 9/16. And that will be what? This is 4/16, so it's 14. 14. It will be 1/4 times 14/16. 2, I have 7, so it's 7/32. You notice what? The area which this approximation is less than my area. I have these missing. So in this case, if I use the left endpoint, my sum will be lower than the actual area. However, if I use this right endpoint, in this case, it's not always true. In this case, using right endpoint, my sum is more than, they call it upper sum. Is because it's more than the area, the actual area. This one, they call it lower sum. So notice, 7/32 is less than the actual area, and the actual area is less than 15/32. So my correct area is the value between these two, which is later we will find it using the integral. Okay, I hope it's clear. Yeah. Let me go to the next one. Same idea now for different function. By the way, in this case, it will be the other way. The area, when I use the left endpoint, I'm getting upper sum. Using the left endpoint, I'm getting lower sum. Okay, let us see it. Now I use how many rectangles? 5 rectangles. And 2 approximations, which is upper and lower, which is using the left endpoint and the right endpoint. So let me do first the right endpoint. 1 right endpoint. See what will happen. Do the same. What will be delta x? B minus A over N. What is B? This is A. This is B. So it will be 2 minus 0. What is N? N is 5. Since I need 5 rectangles over 5. So that will be 2/5. And then the intervals will be what? 0 to 2/5, which is this one. Also the same here. And that will be 2/5, 4/5, 4/5 to 6/5, 6/5 to 8/5, and the last one, 8/5 to 1. Okay. Now, if I'm using right endpoint, it means what? I have using right endpoint. I'm using this point. Huh? Okay. So let us see what will happen. Now my function is this. This is my function. So I have delta x, which is the width, which is 2/5. This is the width. For the height, I need to be careful in the calculation. Oh, okay. That will be what? F of 2/5, F of 4/5, F of 6/5. Since I'm using right endpoint, huh? F of 8/5, and F at 1. Okay, what is F 2/5? Do the calculations quickly. That means minus 4/5 plus 5. Correct? Yeah. Minus 4/5 plus 5. And that one is minus 4/25. Sorry. Plus 5. Square of this. Minus 4/25 plus 5. This one is minus 16/25 plus 5. This one minus 36/25 plus 5. This is minus 64/25 plus 5. This is 4. Minus 1 plus 4. Minus 1 plus 5, which is 4. So what will be the area? It will be 2/5 times this, which is minus 4/25 plus 5. Minus 16/25 plus 5, plus 36/25 plus 5, minus 64/25 plus 5, plus 4. Which is what? 2/5 times what I have here. I have 5, 5, 5, 4. This is 19. Minus. I have 4, 20, and this is 100, correct? So it's minus 120/25. So that will be what? Just a matter of calculation. We need to do it carefully. 19 times 25 is what? 20 times 25 is 500, correct? I subtract 25. That will be 475. 4. Yeah, you can check. 25 times 19. 45. 422. 475, which is the same answer. Okay. So that will be what? Will be 2/5. Okay, 475 minus 120. That will be 355/25. Correct? Yeah. Okay. Now over 5, this is 1. This will be what? 71. Yeah. So I have 142/25. This is the right endpoints. 142/25. Well, it's very clear. This one, I'm losing some of. So this is f of this, f of this. So I'm losing some of this. So this will be less than my exact area, not like this one. It's very clear. If it's increasing, the area will be more. If it's decreasing, the area will be less. Okay. That is one thing to look at it. Now let me do the left endpoint. Left endpoint. We'll do the same thing. What will be my delta x, which is the width? 2/5. the intervals. So I'm using what for the height? I'm using f at 0, f at 2/5, f at 4/5, f at 6/5, f at 8/5. I'm using the left endpoints. In this interval, I'm using these left endpoints, not the right one, and so on. Okay, initial interval. Now, what will be f of 0? Don't forget the function. Then I need to do the calculation. That will be 5. That will be -4/25 plus 5. That one will be -16/25 plus 5, -36/25 plus 5, -64/25 plus 5. Okay, so the area for the approximation, this is the approximation. By the way, this is, they call it L4, so they call it L5 in this case, or since it's the right endpoint, they call it R5. Okay, and this one they call it L5, left endpoint. Or let me call it areas. Then we'll discuss that, since it's lower and upper. Yeah, let us approximating area. Forget about that. So what will be this? It will be 2/5 times what? 5 minus 4/25 plus 5 minus 16/25 plus 5 minus 36/25 plus 5 minus 64/25 plus 5. And that will be 2/5. 5, 5, 5, 5. This is 25. Minus 20 minus 120/25. And 25 times 25, then it's 625. So it will be 2/5. 625 minus 120/25. And that will be what? 2/5. Here I have 595. Huh? No, 605. What is this? 605/25. 5. So I have what? 1 to 1. So that gives me what? 242/25. Very clear, it's more than this one. So my area, the exact area, is between these two values. Notice in this case, in the right endpoint, it will be lower than the exact. In this case, the right endpoint is more than the exact. Yeah. Okay, and the same thing for the left endpoints. Okay. So now we have something called lower sum. We have something called upper sum. What is the lower sum? Which is if the sum is lower than the expected or the exact area of this approximated sum. If it is more, then, and it's related to being increasing or decreasing. If it's increasing, for sure, the right endpoint will be more. If it is decreasing, then the left endpoints will be more than the exact area. Okay, let us do more problems. Find the upper and lower sums for the region bounded by this. You want the upper and lower sums. Okay. Yeah. So here we are doing it for any n. This is for any n. So I'm doing it in general. for any n. Okay. So what will happen? This is the function. This is the function. Y equal x square. I need it only from 0 to 2. From 0 to 2. X equal 0, x equal 2. The graph bounded by the graph of y equal x square and the x-axis. And the line x equals 0, x equals. So I'm looking at this interval, this area. This is what I want to approximate. Okay, using the lower sum and the upper sum. So the upper sum, if you notice, now we will do the rectangle here, like what we did in this one. Like what we did in this one. It's similar to this one. So these are my rectangles. So what will happen? The right endpoints will be the upper sum, and the left endpoints will be the lower sum. So for the upper sum, I need what? Right endpoints. And for the lower sum, I need the left endpoint for all the case. Since the function is increasing all the way. Whether it's increasing and decreasing, then I need to split it in 2 parts. And I think we will see some problems later in one of the old exams. Questions. Okay. So now the upper sum will be what? I have delta x, which is what? Now I'm doing it for any n, in general. Delta x will be b minus a over n. So that will be 2 minus 0 over n, and that will be 2 over n. Okay. Now, if I want to find the heights, now I need to do the heights in the right endpoints. Yeah. If you notice, this will be 2 over n. Yeah. If I want to split the intervals, that will be 0. That will be 2 over n. Okay. That will be 4 over n, up to n over n. In other words, we can do it this way. We say, we can use these formulas, which I will talk about. Actually, I should have it here. I forget about it. Okay. So these are the formulas which we will use. Okay. This is for the right endpoint. So I have delta x equal this. Xi will be a plus I delta x. What is my a? Is 0 plus 2i over n. What is 2i over n? Actually, this is what we did, but we do it with values, huh? So we have the same thing here. Here in this one. So I have to take 2 over 5. All right, 2 times 1 over 5. This is 2 times 2 over 5. 2 times 3 over 5. So it's 2i over 5, since I'm starting with a equals 0. The same formula. So I need to use this formula. خلاص. The area, the upper sum. Why is the upper sum? Since the function is increasing, it will be delta x. What will be the height of each rectangle? The height of each rectangle, or the area of each rectangle. The area of each rectangle. Let me do it in steps. Will be what? Width times height. What is the width? The width is delta x. What is the height? F of xi. So that give me what? 2 over n times xi, which is 2i over n. That give me, or not 2i over n. f of 2i over n, sorry, f of 2i over n, which is f of these points, f of these points, okay, the right endpoints, okay. That will be 2 over n times, I need the square of this, which is 4i square over n square. 4i square over n square. Okay. Now that will be what? That will be 8i square over n cubed. This is the area of each rectangle. The total area, or the total upper sum, the total upper sum, now I need the summation. Total upper sum will be the sum of these, will be summation, I equal 1 to n, 8i square over n cubed. Since I have n rectangles, and I have n rectangles. For any subdivision, I have n rectangles for any n rectangles. Huh? Okay, I'm having n rectangles. So that will be total, which is what? Now 8 over n cube is not related to the I equal 1, is not related to I, so I can take it outside. And this will be summation I equal 1 to n of I square. You remember I told you we need to memorize these formulas. Now I need this formula, so I need this formula in this case. That will be n times n plus 1 to n plus 1 over 6. And that give me 8 over n cubed times n plus 1 to n plus 1 over 6. That will be what? This one is n squared plus n. I have 4 over 3 n cubed times what? This is equal. And this is 2n cubed, correct? 2n cubed. I have 2n square plus n square plus 3n square plus n. So that give me what? 8 over 3. 4 times this n cubed goes in n cubed plus 4 and 4 over n. Yeah, let me do it in steps. Yeah, that will be 8 n cubed over 3 n cubed plus 12 n square over 3 n cubed plus 4 n over 3 n cubed, which is equal to 8 over 3 plus 4 over n plus 4 over 3 n square. So that will be my uppers for any n. Now take in any value, then you get the answer. Okay, now for the lower sum. Yeah. And by the way, to find the area, just take the limit. As n goes to 0, so the area should be as n goes to infinity. We'll make n goes to infinity. For sure, I'm getting the exact area. Okay, if you look at this one, if we take, now I take here 4 rectangles, that give me this. If I take more rectangles, then I'm getting an accurate calculation. If I let n goes to infinity, I'm getting the exact area. So for sure, my exact area will be 8 over 3 here. So as it goes to infinity, all of this goes to 0. Okay. Now we'll go to the total lower sum. Lower sum. Okay. Now I need to use different formulas. I need to take left endpoint, left end points. Okay. What will be the left end points in this case? The same thing I have in rectangles. Okay. Delta x will be the same. It will be what? 2 over n. 2 over n. Here is the trick. xi will be a plus I minus 1 delta x. Since in this case, I want this. In the first n, I need the 0. This is the first one. This is the second one. So in this case, in this rectangle, I take this one, which is the 1. You get me? This will be, in this, I'm taking xi, a plus I delta x. No, in this case, I will take the I minus 1. So in case of this, x1 will be a, which is 0 in this case. So xi will be a plus I minus 1 times delta x. And just plug the numbers. So I have a equals 0. That will be 2 times I minus 1 over n. I will do the same calculation now. What will be the area of each rectangle? Area of each rectangle. It will be delta x times f of xi. I minus x of, yeah, which is the previous one. Usually they call it I minus 1. Yeah, it depends on how you call it. Which is what? 2 over n for, no, be careful. That will be 2 over n f of this, which is 4 I minus 1 square over n. That give me what? 8 over n cubed times I minus 1 square. So it will be the lower sum will be the summation I equal 1 to n of this 8 over n cubed I minus 1 square. Now I'll open this 8 over n cubed. That will be I square minus 2i plus 1. Okay, now we'll do the calculations. That will be 8 over n cubed. So I can take it out. The summation. It will be summation I equal 1 to n of I square minus 2 summation I equal 1 to n of I plus summation I equal 1 to n of 1. I square, we get it before. It will be n plus 1 to n plus 1 over 6. This one, let us remember the formulas. It will be this one, n times n plus 1 over 2. And the last one, n. That will be n plus 1 over 2. Then forget the 2. It's 2 times this, minus 2 times this, plus this one, which is n. Now let us do the calculation. 8 over n cubed. Here I have what? This is cancelled. So I have minus n square minus n plus n, which is minus n square. So I have this, which is we did before, correct? N times, it will be 2n cubed plus 3n square over n. Yeah, where is it? Where is the space? Yeah, here. So I have, this is n square plus n. It's easy to remember. So that will be 2n cubed plus, here I have n square plus 3n square plus n over 6 minus n square. So let me simplify it. That will be what? Minus 6n square. So that will be 2n cubed minus 3n square plus n over 6. Okay, and that is what? That is 4 over 3n cubed times what? Yeah, well, just let me, yeah, this is 4 over 3. So it will be 8n cubed over 3n cubed minus 12n square over 3n cubed plus 4n over 3n cubed. In other words, it is 8 over 3 minus 4 over n plus 4 over 3n squared, which is almost the same as this one, but this is plus, and this is minus. Because with that, this is a lower sum. And you notice as n goes to infinity, I'm getting the same value, which is 8 over 3. And that would lead us to the last things in this section, which is to find the area. I'll use either right endpoints, left endpoints, midpoints, any points you like. We do this limit, this summation. Then if I take the limit, I'm getting the area of the region. So what will be the area in the region, which we did in the first one? Yeah. What is the area in this region? It will be 8 over 3. Since n goes to infinity. Now let me do this one completely to prove that is 1 over 3. I will use the right endpoint. You can use either the right endpoint, the left endpoint, it's up to you. Show that the sum of the areas approaches 1 over 3. Use the left or right, you'll get the same answer. So let me do it, and then I will stop. Okay. Now this is the function. I'm using the right endpoint. Right endpoints. Okay, the function is x cubed. Delta x will be what? B minus a over n, 1 over n. The heights will be f. Remember, after find the delta x, we'll find xi, a plus I delta x. That will be 0 plus I over n. The height, f of xi, which is I square over n square. The sum will be summation I equal 1 to n delta x, the width, times the height. And that give me what? 1 over n cube outside, and this summation, which is 1 over n cubed. Remember the formula, n plus 1 to n plus 1 or 6. The area will be the limit as n goes to infinity of this sum. And it will be the limit as n goes to infinity of this one. Remember these things. This is n squared plus n, so I have 2n cubed. Correct? 2n cubed plus 2n plus 3n square plus n over 6 n cubed. So it's the same degree. So just I divide the coefficient. That will be 2 over 6, which is 1 over 3, which is the area I'm looking. If you use the left endpoints, let me do it. Now, what will be delta x? It's b minus a over n, which is 1 over n. xi minus 1 I will use, which is a plus I minus 1 delta x. So the width is 1 over n. The height will be, which is what? A equals 0. So this is I minus 1 over n. Huh? the height, which is I minus 1 square over n square. The sum will be what? Summation I equal 1 to n, the width times the height. And that give me what? 1 over n cubed, summation I equal 1 to n, I square minus 2i plus 1. And that will be 1 over n cubed times, what is this? n plus 1 times 2n plus 1 over 6 minus 2 n plus 1 over 2 plus n, huh? Summation. We did it before, huh? And actually this is gone. This is minus n squared. So this is, everything is minus n squared. So that will be 1 over n cubed times what? n plus 1 to n plus 1 over 6 minus n squared. When you do the calculations, that will be 1 over n cubed. If you remember minus 6, that will make it, yeah, that we have 2n cubed minus 3n squared, huh? Because you have 2n, you have 3n squared, you have this what? This what is 2n cubed plus 3n squared plus n. So that will make it minus 6, so it's minus 3n squared plus n over 6. So that will make it what? 2n cubed minus 3n squared plus n over 6n cubed. My area will be the limit as n goes to infinity of this. Same degree, so you have 2 over 6, which is 1 over 3, which is the same area as I'm looking for, using the limit as n goes to infinity. Either I'm using right endpoints. Actually, he wanted to find the Rn. I'll find it for all. Yeah, I think this is enough for today. So let me stop here. Thank you.